Hi, I'm Lorie Miller and I teach 5th grade science at Oakdale Middle School in Allen Parish. My passion is to create meaningful relationships with my students and their parents to increase our parental involvement, especially since we're an impoverished school. This year I use PhD science to teach my lessons. This lesson goes back to the mangrove tree, which we've been covering for several weeks now, and how the mangrove tree is an ecosystem and plants and animals interact within that ecosystem. So today the students had to show how decomposers break down dead things and how that matter is cycled through an ecosystem. To begin the unit, we did a driving question board and our students came up with 2 major questions that they wanted to answer based on the mangrove tree. They wanted to know how plants got their energy and how plants received their food, and then they also wanted to know how animals ate and received food and grew and got their energy. So we've been working to answer those questions the last couple of weeks, and today we brought all of that together to show how plants and animals interact within an ecosystem. Most of my students in this class are higher achieving level students, so try to give my students as much choice as possible. Even though I do follow PhD with fidelity, I do like to give my students choice so that they can feel like they own their own learning.
Our learning target is, I will explain how matter cycles among plants, animals, decomposers, and the environment so that I can model the movement of matter. We're going to continue on talking about matter and how it moves through an ecosystem. In your group, I want you to take your bingo chips and create what you think, like you're going to pretend that each little bingo chip is a piece of matter, okay? So you're going to create like a plant, like this, okay? So you're going to have a little stack that represents a plant, okay? Then you're going to have a little stack that represents a decomposer. Plant that has died, what comes into play? A decomposer. Say it loud so we can hear you. What? A decomposer. To begin, I need to answer my first question so I can get this in my brain and I can start thinking about what we're going to talk about today, okay? What is a decomposer?
What is a decomposer in your own words?
What is a decomposer? I'm on slide 2. No, 3.
And? What else
Slide 3.
What else is a decomposer?
As we do this little activity, you're going to answer these questions, but I only want you to answer number 1.
Very good.
Raise your hand and tell me. What does a decomposer do, Sine? Okay, she said a decomposer breaks down dead animals and dead plants. She's right. Anything else about a decomposer that might be pretty important? Peyton?
It takes the nutrients from the dead plants and animals and gives it back to the...
Okay, so, and Peyton said the decomposer gives those nutrients back to the environment. Here's where your little stacks come in. That represents a plant, and this stack represents a decomposer. How could I show that decomposer is breaking that plant down?
It would break it apart?
Yeah, like a part, because
So-
it's breaking it down, so maybe it's...
So it looks like right here you're giving the decomposer, like you're taking from the decomposer and giving it to the plant because this was a plant stack. So shouldn't it be the reverse?
So they break down the dead stuff. They break down the dead animal, something like that. They break it down so it could, like, put these 2 and these.
So what's happening?
The decomposer breaks down the plant, and the plant's nutrients goes to the plant.
Okay, so I see how you had red and blue here, and you put a red and blue on the decomposer. Why'd you do that? I'm not saying you're incorrect. I just want you to talk through it. The nutrients in the plant from the plant went to the decomposer. Great job. Great job.
Basically, have the nutrients,
Okay.
and then it like puts it back into the soil.
Great job. Awesome. So that tells me about your understanding of decomposers. You know that decomposer takes things from that plant, keeps it to itself, and we didn't do this part, but later on it's going to give that back to the environment.
This is the like nutrient link thing. Take the stuff out of the and bring it back to the environment. And then it starts shows that the decomposer is taking away from the dead animal's nutrients, and that nutrients obviously goes back to the decomposer, and then the decomposer releases it back into the environment.
Like, say food makes us something, so nutrients is kind of like food for them, so it makes the ecosystem.
What we're going to do is we have made simple food chains in here the last couple of days. You're going to do that, but what I want you to do, I kind of started mine over here. I know that plants use energy from the sun to make their own food, right? Something we talked about a long time ago. Plants use energy from the sun to make their own food. I want you to draw a model showing if I have a plant, you see this red dot? That's like a piece of matter, okay? So an animal would come and eat this plant and it would take on that matter. So where would the red dot move to? To whatever animal you have. And then I want you to continue it on, but what should you finish your model with? Drawing a model of how a piece of matter, so if you need to make a dot, you don't, like this little dot means matter, okay? And so when this animal eats it, it goes to that animal. And then it's going to keep going, okay? And you're going to show me how it moves in an ecosystem. Oh yeah, you could have, yes, seaweed is great. Seaweed's a plant. What would eat seaweed? Fish? Yeah. And then you could do a small fish, and then what would eat that? Big fish. Very cool. Because I'm going to let you talk about it with your neighbors in a minute.
I know my rabbit is absolutely terrible cold.
Put that red dot right there.
A smite or a wolf.
Do they have wolves in the desert?
Don't sit and wait for a color. Go get you one, okay?
Gary, Jackson. But which one are you on?
Let's just do a fish and then put like some spikes right there. It's pokey they are.
Okay, but look, should it be? If I'm eating this, yeah, you've got to move the dot too, because that's what's showing. You see what I'm saying?
I tried to. Okay, that didn't work out. Okay. Sunflower. Got it.
Okay, so you got flower, and the matter's going from the flower to the mouse, rabbit, hawk.
The bunny is the plant, the fox eats the bunny, the fox dies and the bacteria decomposes the bunny, the bacteria goes to the matter back to the soil.
And what kept
And you've compared your model with your neighbor, and you've discussed your model with your neighbor, and finished this slide. I want to talk about it. I want to share out. What was your model? Like, what did you notice in your model, or what did you notice in your friend's model? Peyton, tell us about yours.
Shows how the matter travels through ecosystem.
Okay, so her model shows how matter travels through the ecosystem. She has a picture of grass, and then she has an animal eating that grass. And then she has another animal eating that animal. Then she has a decomposer. And we know that decomposers break down and give back to the environment. Animal tissue in the mangrove tree ecosystem. We're relating it back to our big idea over the whole module. Grew this mangrove tree, the animals started eating off of it, then other animals started eating those animals, then humans ate those animals, and this matter started cycling through, and the ecosystem did what?
It expanded.
Yeah, it expanded. I like that word. It expanded. I really like your answer. I really, really like that answer. Awesome. Okay. A lot of you are having really excellent answers with those vocabulary words that we've been using. So what happens to this dead plant material, this matter, this energy?
They get decomposed, and the decomposers release that energy into the soil for the tree and the plant.
Okay, Kyla, I really liked how you worded yours. Kyla, tell me what yours says.
The matter goes back into the environment.
Okay, the matter goes back into the environment, which is exactly what Alex said, but he said it in a different way. Anybody else have anything different? The soil, Natalie?
I said when these things die, whenever these plants die, matter goes into the soil creating nutrients.
Okay, and matter goes to the soil, giving nutrients to the soil. What can we say that matter does what in an environment? It starts here, it goes to the end, and it goes back. What is that called?
It makes a cycle.
Okay, but what's a different word for circle? Somebody said it. Say it loud. Cycle. So can we say, do you all agree that we can make a statement that says matter and energy cycle through, whoop, my arms got caught. Through what? Through the ecosystem. I like that. I think that's a great statement. It's straight, it's to the point. It takes what everyone has said, combines it into one statement. And that's what we have shown today, that matter does cycle through any ecosystem. It doesn't matter. I'm going to give you this, work on it, and as we dismiss, you can give it to me at the door.
After the lesson, I feel like my students really did meet the objectives. I'm not sure that they all mastered the objective, but I do believe that they all at least got to some part of the objective. This is still relatively new to them, cycling matter through. Even though we've been talking about plants and animals for the last several weeks, we've only been talking about cycling matter, or really food chains, I guess if you want to call it that, for about a week now. So I feel like they are developing their expertise in that area. If I were to do this lesson again, I think that I would kind of slow down. I feel like I kind of rushed them in some parts, and I wanted to make sure that their discussions were in depth, and I feel like maybe some of their discussions were a little surface, and I could have dug deeper. I feel like if I did this lesson again, I would tweak some things and take away maybe some of the beginning part and give more time devoted to the devote more time to the actual learning part of the lesson. Tomorrow they will come in and we will use what we've been talking about to go over some Eagle questions. I try to incorporate Eagle items into my lessons as often as possible so that students are used to that leap-like assignment and used to that leap-like terminology. I help them break those tasks down. So that's kind of where we're leading to next, is getting some of those Eagle leap-like questions done and those tasks broken down so that my students really understand what's being asked of them. One thing that I do feel has really increased this year, especially with this class, is their use of content vocabulary. Science is so content vocabulary driven. If they don't know how to properly use those words, it's just really detrimental to them. So I try to teach my students those words and how to use those words. And not only that, how to interchange words that might mean the same thing. But I feel it's very important to make sure that they're making those connections and knowing not only the content terms, but how to properly use those in their discussions, because those are the types of terms that they will be measured by on standardized testing. Overall, I'm very excited for my students. I feel like they really did what they were supposed to do today. I felt like they learned. I felt like they really interacted well with one another and discussed and had those higher thinking moments. I'm very proud of my students, and I feel like they were very successful today.